All right, back to our esterification reaction. Esterification. We take a carboxylic acid plus an alcohol, and we form an ester and water. All right, so look at your worksheet, and you see I've got their acetic acid. Did we do that one yet? Acetic acid plus isopropyl alcohol? Go ahead and do that. Draw out those structures. You're doing an esterification. You're going to take a carboxylic acid, acetic acid, plus an alcohol, isopropyl alcohol, draw out the structure, and name the product. There's two or three of you, and your names will be unmentioned. Hey, we haven't been up here yet. Okay. And if you don't remember walking up here, then you know who you are. If you'd like to come up and do this reaction. Don't worry about getting it right or wrong. If you're up here, that's a yeoman's try. This one where it says esterification reaction, acetic acid plus isopropyl alcohol. Yeah, I've given you so many papers, they're probably hard to keep track of. Okay, and as soon as you're done with that one, if you turn the sheet over, there's another esterification reaction. And don't go on from there, because we haven't talked about hydrolysis. We haven't talked about those last two reactions yet. is cyclohexanoic acid. Yeah, you need a circle in there. It needs to be aromatic. Right, so you need a circle in there.
So that's it?
Well, that's benzoic acid, yeah.
Okay, I was trying to guess.
Yeah, that's benzoic. Yeah, that's a water.
Yeah, I was just trying to take them out.
Yeah, you get rid of 2 H's and no. Sorry. Okay, no, that's pretty good. That's pretty good. Let's take a look here. At OH, where is that OH? It's on that carbon. What carbon did you bind this to? You bound it to that carbon. What would this look like? What would this look like if this was bound to this? This one. Yeah, you can have you got to twist this over here. You got to have a carbon come up here and a carbon come down here. Okay, so it is the carbon that bears that OH that ends up bound to this oxygen right here. And so you got it on the first carbon, not on the second carbon. So see, so rearrange it. Yeah. Okay. There's two of them down there. Go. One second. Think of this.
Oh, because it was the H's.
Yeah, they're all H. They're all H.
I was confused. I like.
And then you can say plus. Go ahead. Plus. Yeah. Water. Yeah. See, that's where this went. This is gone. This and that is the water. Two H's and no makes the water. That's better. Plus what? Yeah, it wasn't in the right location. That is the most common mistake when someone reacts isopropyl alcohol with it, they end up attaching it to that carbon. Yeah, then it, right. That when they're done right. Exactly. Okay? Okay. Okay, here's the first one here. Acetic acid plus isopropyl alcohol. The most common mistake students make with this kind of situation is they attach the propyl on the end. This carbon can't attach here because these hydrogens are not going to react with that. It's not a hydrogen reacting with a hydrogen, it's an OH reacting with a hydrogen to make the water. So here is your isopropyl acetate. It's attached to the middle carbon. Isopropyl acetate plus your water. All right, so that's the name of this here. Where are we getting the name? We're going to pull the name of the alcohol in as the front name, isopropyl. That's this thing right here. And acetic is going to become acetate. And what is the other name of this? This is the common name. What's another name of this? Isopropyl. See how you pack name of this? Ethanoate. What?
How do we get ACE?
ACE?
Yeah, where's ACE come from?
I don't know.
Is it always in F?
Yeah. So acetic acid has 2 carbons. Acetaldehyde has 2 carbons.
2 carbons. So it means 2 maybe?
Yeah. I don't know what ACET, what that prefix means. You're going to find another one in chapter 15, acid amide. An acid amide is a 2-carbon amide. See how that helps me a lot. But you'll learn what amides are in chapter 15. Blessing, did you have another question? Answered it? Okay. Okay. We're doing great here. I put a little schedule over here. This was going to be on Thursday, exam. I think I'll just give you one more day to digest all of this. But I don't think if we push it over to Monday, next week will be nothing but exams. I mean, you'll be so worn out from exams because we're going to have a lab exam, we're going to have a exam 3, a final exam. So we really need to push through to get this week, Friday. But it will be chapters 13, 14, and 15. I'll get into, we'll start biochemistry on Thursday. And you kind of get started in there. Might even finish that chapter on Thursday, but you can kind of set it aside. We'll do the exam. Yeah, we'll see what we can do here on Friday. We'll do the exam on Friday, either right at the beginning or middle or end or something. But we'll be shooting for that exam on Friday.
So the final two games are back to back?
Yeah, there'll be exam 3 on Wednesday, and then a little more lecture after that, and then the final exam on Thursday. Okay? So, what? About 7. Okay. Let's carry on here. In the lab, not all of you are in the lab, but we're going to make aspirin eventually. And when we do make aspirin, we're going to be forming an ester, acetyl salicylic acid. Acetyl salicylic acid. It still is a carboxylic acid, but it is also an ester. That's aspirin. Polyesters. Everybody's heard about that. Polyesters. It's fabric. And you can take ethylene glycol, an alcohol, and this terphthalic acid, and it's got a carboxylic acid. So what do you got here? You've got a benzene ring with a carboxylic acid on both sides. So it's like benzoic acid, but it has another, in the para position, it has another carboxyl group. Here is an alcohol, but it's a diol. It's got an alcohol on each end of it. So what do? You form an ester, and it can go on and form, this end of the molecule can form an ester with another terphthalate, and you get PETE, polyethylene terphthalate, which is an polyester. And guess what that bottle's made out of? This bottle right here, my bottle, too. PETE. This is a polyester. Now, if you melt this down and spin it into fibers, you get polyethylene fibers, polyester fibers. Not polyethylene, polyester fibers. So you melt it and you pull it, and it'll make a fiber, and you can make clothing out of it.
Technically, polyester is not healthy to wear.
Is what?
Not healthy to wear.
I don't know.
Well, because you said that the chemicals would leach out of that when it's heated up, right? So wouldn't it, if you spray, it would leach out?
No, this is okay. This is okay. I said polycarbonate will leach out bisphenol A. You might get some chemicals out of this, but shouldn't get too much. Otherwise, we shouldn't drink it. Yeah, if you work at Valero, close your ears. But like when you go into a Valero gas station and they have pallets of drinking water bottles sitting out there in the sun, don't buy it there. Buy it at HEB or somewhere that they're taking it off a truck and they're putting it inside, and they're not sticking these things out in the sun. All right? Because I don't know what's happening chemically, but something could. You've got ultraviolet light hitting a plastic, and you got drinking water inside of it. I should say that, but actually, I read an article. There was a school in a country where the drinking water wasn't very good. The schools had very high absent rates because the children were always sick. You know what they did at those schools? They took the water like this. They just put the regular drinking water, came out of the tap, but was contaminated, and they put these up on the roof of the school in the sun, and they had the kids drink that water, and the illness rate dropped. Why? Because the ultraviolet light was killing the bacteria in the water, and the kids were actually not getting sick as often because they were drinking cleaner water. There's other ways of doing it. I mean, you could take the water and come up with a filtration system or something like that. But basically, the children were always sick because they were drinking contaminated water. And that was one way that they decontaminated it, in the light, in the sunlight. It'd be better to put it in glass bottles and put it up on the roof of the school. Glass bottles will absorb some of the ultraviolet light. So I don't know.
So maybe that absorbs.
Yeah. Okay, so PETE is a plastic polyethylene terephthalate. Nomenclature, this is what we've been talking about. Ethanoic acid, methanol, you get methyl ethanoate. If you want to come back and kind of review this is come back to these slides. This is how you piece these names together. And notice, methyl ethanoate is also methyl acetate. So be real comfortable with acetic acid being acetate, being a 2-carbon feature there. Here's some more names. Ethyl butanoate, propyl ethanoate. So here's the propyl. Over here we've got the isopropyl. You can see the way it's attached. Propyl attached right on the end, isopropyl attached in the middle. Again, names. How are we piecing them together? We're pulling the front end name off of the alcohol. It would have come from the end of the name from the carboxylic acid it would have come from. All right, the next reaction. Now we're talking about, I've got an ester. How do esters react? Well, you could react esters with water. Okay, so find this sheet right here. And I misspelled it. I can see it's hydrolysis. S-I-S. I quit before I got to the end of the word. I need an S on there. The hydrolysis of an ester. So what goes in those blanks? An ester plus water is going to produce a carboxylic acid and an alcohol. Hydrolysis, what should come to mind is water. We're reacting, the hydrolysis of an ester, we're reacting an ester with water. You can see that this is the opposite, the reverse of esterification. This is esterification in reverse. We're starting out with an ester and we're producing from it a carboxylic acid and an alcohol. All right, and here is an example. Here's an example. We got propyl propanoate. We're starting with an ester. We're going to react this ester with water. All this is saying is it's in an acidic environment. It's a somewhat acidic, and maybe warm it up a little bit with a little acid present, like sulfuric acid. And it's going to break this bond. What's it's going to do is it's going to insert this water molecule in here. Here's our H2O in blue. We're going to get an H on the propanoate and form the carboxylic acid. We're going to get an OH on the propyl and form the alcohol. Acid hydrolysis of an ester.